Here we're going to subdivide a segment or a triangle by a given ratio. And we're going to do this just through an example starting with a triangle. We're going to divide this triangle at a given ratio of 3 to 1. So if I have a ratio of 3 to 1, this means that I want to have 3 parts to 1 part. So another way would be with these double dots or the colon. Now I could also think of this as I want 3 parts of the total that's there, which is 4 parts. And there's no coincidence that that 4 is equal to 3 plus 1. So I want to scale this triangle down to this length only being 3 of its 4 parts long. So in order to do this, I want to think about what is my change in rise. My change in rise is given to me by 5 minus a negative 7. 5 minus a negative 7 is 12. And what is my change in run? Now my change in run is given to me by 8 minus a negative 8, which is 16. So I have my rise and I have my run, but I need to apply my ratio to it. So I'm going to multiply both of these by 3 over 4. 12 times 3 over 4 is 9. 16 times 3 over 4 is 12. So from A, that means I am going to move up by 9 spaces. So I'm going to move up from negative 7 to a positive 2. And I'm going to move to the right 12 spaces from negative 8. And my new ending point for X is going to be a 4. So my point that occurs at 4, 2, and we can call this point P. P marks the triangle that is 3/4 the size of the triangle that we started with. And we can apply this in some other ways, but I want to go back to looking at constructions. How could I break a line down into equal parts? So if I have line AB, and I want to know what is 1/3. What is 1/3 of this line? So that's the ratio that I want. What I'm going to do is I'm going to construct an angle. And the angle that I construct really doesn't matter. I'm going to construct it from A, and I'm going to let it just go on forever. Now what I'm going to do is I'm going to create an arc. Some arc, and it doesn't matter of the length. I've just chosen a random length. And I'm going to put 3 marks on my page, starting from A on my new ray. So I'm going to say 1, 2, 3. And if my ratio is 1 to 3, I'm going to actually change that to 1 to 4 so that I'm not doing the same as the last problem. Or did I say 1 to 4 or 1 to 2? So I have 3 total parts. I'm going to connect this point, the third part. So I have part 1, part 2, part 3. And I'm going to go ahead and connect that third part to my point B. Now in a previous lesson, we revisited constructing angles. So what I'm going to do here is I want to be able to redo this angle right here. So I'm going to call that point P. So I want to recreate APB at these other 2 segments. So really simple. Some length. And I'm going to construct an arc from point P all the way around. And I'm going to construct that same arc at my other 2 intersections. Now all that I have to do is measure the angle from this intersection above P down to my line PB. And I get this length. Now this length is the length of the arc, and it's the same length on this arc, and the same length on this arc. So now that I have all of these intersecting points, what I am capable of doing is connecting this intersection with this intersection, my first with my first, my second with my second. And I get this first segment, this second segment, and this third segment. I have divided A, B into 3 equal parts. So if I wanted to build a ratio of 1 to 2, this point right here, X, is a 1 to 2 parts. Now if I wanted a 2 to 1 part, then that would be located here. So this is a way using old techniques of the constructing or reconstructing angles using a compass that we can go ahead and divide a line into equal parts. So if I want to make 3 parts, I need 3 intersections. If I wanted 5 parts, I would have to create 5 of them. Remember, math rocks with a capital M.